So this session is related to line and continuous spectrum and the excitation of the electron within an atom, which leads to different spectrum. So northern lights and southern lights occur when charged particles emitted by the sun are deflected by Earth's magnetic field. As a particle travel through the Earth atmosphere, they collide with atom in air, and that resulting in production of streaks of light. The photograph shows a streak of light that can be observed across the sky, close to the north and the south pole. So basically what happened, as sun is emitting out charged particles, and when these charged particles, they are deflected due to the magnetic Earth's magnetic field, so they enter the Earth atmosphere. As a result, when these charged particles enter the Earth atmosphere, it causes a deviation. So when these charged particles enter the Earth atmosphere, they deviate, deflected, and they collide with the particles in the atmosphere. And as a result, when they collide, they transfer the energy and cause these atoms become excited. What is the meaning of atom become excited? Because these atoms have shells, different elements have different shells, and these electrons which are present in an atom, they jump, absorb energy from the charge by collision of the charged particle, they jump and return back, they release a certain energy photon. This is what happened. The question is, explain how the light is emitted due to the collision between the charged particles and the atoms of the gases in air. So how this light is produced? So first, what happened when these charged particles collide with the atoms, the electron gain energy which are present in an atom, and these electron, when they gain energy, they move to higher level, and when the electron falls back down, it emit out energy, or of energy in the form of particle or photon, and the photon energy is equals to difference of energy of the two levels, and this will give a characteristic color. And if energy of the photon is more, it means it will have a higher frequency. So when the charged particles collide with atoms, the electrons inside the atom gain energy and jump to higher level. So these electrons, when they gain energy, these electrons will jump to higher level. And then when electron fall back to the lower level, it release a photon which has energy equal to difference in the which is having the energy equal to difference in energy of the two shells, and energy emitted out depends on difference in the levels. If they have a greater difference, more energy will be released, and high frequency will be there. So this is what happened. So the question in the beginning, they asked that from the sun, these charged particles are coming out. As a result, when these charged particles are coming out, they enter the Earth atmosphere, they're deflected by the Earth because magnetic field is stronger on the poles. That's why we see these northern and southern light on the poles only, not on the equator, as these charged particles deflected towards the poles. As a result, when these charged particles are deflected, the particles collide with the particles of air which contain nitrogen, hydrogen, nitrogen, helium, oxygen is there, carbon dioxide. So when these charged particles collide with these atoms in the atmosphere, they cause the electrons to jump from one level to another. So electrons which are in the lower level, they collide with the charged particle, gain energy, and these electrons jump. And when these electrons jump, they will remain there for some time. And when these electrons return back, they give out a characteristic energy which is equals to difference in the energy of the two levels, or they will give out a characteristic photon. The next part, the green color commonly observed in an aurora is caused when the charged particle collide with the oxygen atom. The intensity of a green color depends on the number of the charged particles and the number of oxygen atom. Explain why. Look, what happened as we mentioned the line spectrum, every element is having shells. The 7 shells are there occupied depending on the number of electrons available. But every element is having these 7 shells. And the gap, the distance between the shell is not same. That is why we call that as a line spectrum is like identity of the element, as different elements have different number of the different gap between the shells. So this was example oxygen. So what happened when the charged particle, positive or negative charged particle, when it collide with this electron, it transfer the energy to the electron. This charged particle is coming from the sun. When it collide, it causes electron, it transfer the energy to the electron, so electron jumps to higher level. And when this electron return back, it give out characteristic color or a photon, and that correspond to, like, that's how different colors are seen. So in case of oxygen, we see commonly green color. So why, the question is why, if we increase, if the number of the charged particle enter the atmosphere increases, or the number of oxygen atoms increases, we'll see more green color, or intensity of the green color will also increase. So as more charged particle enter the earth atmosphere, so they will have a greater number of collision, like there will be greater number of collision between the charged particles and the atoms of oxygen, and greater number of collisions between the charged particle and atom of oxygen. So more excited atoms will be there for oxygen. That is the result, more photons. That's why the intensity will increase. So the answer here, when number of the charged particles and oxygen atoms increases, so there are more collisions. Even you can write excite the atom or excite the electron, both are having the same meaning. So when number of charged particle in oxygen atoms increases, so there are more collisions between them, which result in large number of excited oxygen atoms. So when electron return back, So more photons will be released when electrons jumps back original level. So increasing the charged particle as well as increasing the number of the atoms of oxygen, it causes more collision between them, and due to the more collision there are more excited oxygen atoms. So more excited oxygen atoms, when the electrons will return back to the same original level, so more energy will be released. Scientists have observed that the light emitted from aurora on other planets. Explain how these observations give information about the gases surrounding the other planet. Like how we know what is the atmosphere of Mars, what is the atmosphere of Venus, how we identify the atmosphere. As we already discussed that every element, the line spectrum is like a fingerprint of the element. So say a planet consists of, there's a planet, its atmosphere example consists of hydrogen and helium. Then there is another planet, atmosphere consists of carbon dioxide. So it means it contains carbon and oxygen atoms. There's another planet, atmosphere consists of, say, oxygen is there, nitrogen is there. So how we identify that what is the composition of the atmosphere? The light, the photon which is emitted out the planet, which is filled with atmosphere is filled with hydrogen and helium, will be different from our photons emitted out from carbon and oxygen, and that will be different from nitrogen, because every element, the shells, the distance between the shell is different, and that is like identity or the fingerprint of the element. So how this information give about the composition of the atmosphere? So each element, each gas is having a unique energy level, and using the energy or the frequency emitted out from these gases, we can identify the element or the gas which is present, and we can, using that, we can identify the composition. So you can mention here, you can generalize, instead of element you can also say each gas, but you, both ways it is acceptable. So each gas has unique, or each element, here I can mention each gas or I can say each element, because elements are different, so that's why different spectrums are seen. So each gas or each element has unique line spectrum, because they have so reason for this, to have a unique line spectrum, because they have different number of the shells, they have different spacing between the shells. So they have unique energy levels. Instead of shell, we normally use the term energy levels, and that emit out. So each gas emit different light or different energy, which can be used to predict the gas present in the atmosphere, or gases present in the atmosphere. Is it clear discussion that how scientists, when they observe the light emitting out from different planets, can leads to uh, conclude or leads to this conclusion that the composition of the planet, the particles, the elements which are present on the planet. In this question, the diagram shows four energy levels of an electron in a particular atom. So there is an element, the shells are shown here. The ground state, what is meant by energy level? What is the definition of energy level? Energy level, it is like region of discrete energy or discrete energy of an atom or electron, or we can also say energy levels are the space where the allowed or the possible energy is there for electron and or an atom. So what is meant by the term energy level? These are refers to allowed energy of electron or an atom. We call them as energy level. Like electron can be here, it cannot be up, or it can, like if we say energy, the level 1, which is a ground level electron, is minus 6.4, so electron will be here. The another, if it is having energy difference like from 6.4 to 3.2, the difference is about 3.4. So if another electron is having energy difference of 3.4, it will be here. So electron cannot be below it, electron cannot be above, so it is allowed energy of electron, or the region where the electron is having a discrete energy, we call that as a energy level. Draw on the diagram two arrows to indicate two different transitions that would emit. So to keep this thing in mind, if they are asking for emission, emission spectrum is only jumping from higher to lower. If sometimes they ask absorption, so absorption is from lower to higher. So we have to mention, indicate with two different transitions that would result in emission of same frequency, same energy. So we have to check the energy difference here. Which two leads to the same energy difference? So when we subtract, like we will check all the possible one. Here 6.4 and 3.2. So what is the energy difference? First I'm writing all of them, and then at the last I will mention what will be the answer. So 6.4 minus 3.2, that is 3.2. So this is energy difference 3.2. If we take this transition, 6.4 minus 2.8, so this transition will be 3.6. If we take this transition, so 0 and 6.4, so this is 6.4. If you take this transition, so 0 to 2.8, so this is 2.8. If you take this transition, so 0 to 3.2, so this will be 3.2. So what are the arrows which we'll draw? Because this transition was 3.2 and this transition is also 3.2. So when the energy difference is same, like this transition is 3.2, this is also 3.2. So if energy difference is same, and we have the formula E is equals to HF, so if energy is same, they will emit out the same frequency. As the plants, H is a constant, and because it's an emission, so you should draw an arrow from top to bottom, like from higher level to lower level. Sometimes the same question, but they ask absorption. So if the same question was absorption, then the direction of the arrow should be different, because absorption is from lower level to higher level. So here we have to show from level 4 to level 2, and from level 2 to level 1. This will lead to same difference in energy. If the energy difference is same, the frequency will be same as well. Is it clear, this part, that how we draw an arrow to show the transition of electrons? The next part, a gas consisting of these atoms can emit a line spectrum. Explain how this happened. Basically, how the line spectrum is, or what is the meaning of line spectrum? Line spectrum means a discrete or a fixed amount of energy is given off. So what happened when electron gain energy? It moves to higher level. Then from higher level, it jumps back to lower level, and as a result, it will emit out. This will be emission, or same thing you can write for absorption. Electron is in a ground state, it will absorb a fixed amount of energy and it will jump to higher level, and because it will absorb fixed amount of energy, that's why it will give a line spectrum. And energy of the photon which is absorbed is equals to difference in the energy of two levels. So when you write electron absorb discrete or fixed amount of energy equal to difference in the energy of two energy levels. This is first what happened, and then when electron jumps back and jumps to higher level, when electron, this is absorption, when electron return back to same energy level, it emit a photon which has fixed energy and leads to emission line spectrum. So how the marks are distributed for this question, how you know that whether you score all the 3 points. So first thing, when you mention that electron gain energy and it move to higher level, that will give you 1 mark. Then you can mention electron become excited, or electron or atom become excited, both having a same meaning, and then electron return back and release a photon equal to difference in energy, that will give you the 3rd mark. One of these atoms in a ground state absorbed 3.6 into 10 power minus 19 joule from a collision with an electron. Calculate the smallest frequency of a radiation that atom may subsequently emit. So we have the energy, we need the frequency. So what we have to do, because we want the smallest frequency emitted, this is like one of these atom in a ground state absorb 3.6 and it collide, when it collide with the electron. So what is happening, like this is an atom, the shells are there, I will show in on the figure. Like these are the shells, electron is there in the ground state, there is electron, and maybe because we normally use like charged particle to collide with an atom, and that charged particle transfer its energy to the atom, and atom become excited or electron become excited. So we use this charged particle, when it collide with this electron, it transfer its energy, cause this electron to jump to higher level, and as a result, when electron will return back, it release energy equal to difference in the energy of the two levels. So we'll see a characteristic color or certain frequency or energy is emitted out. That is what happened. Now in the question, we need the smallest frequency. Smallest frequency means the smallest energy, and which is having the smaller difference in between the energy level. So when we check, which one is having the smaller difference? So the smallest transition is this one. This is the smallest. Because in the question they're asking which is the least smallest energy or the frequency which is emitted out or given off or absorbed. So that is, we need a smaller gap between the two levels. So how much is this gap? That is 0.4. And the exponent into 10 to the power minus 19 joules. So this is the energy which the photon carry, and using this energy we can work out the frequency. So E is equals to hf, where E is the energy emitted out, so 0.4 into 10 to the power minus 19. H is a Planck's constant, which is a fixed value, 6.63 into 10 to the power minus 34. So this is 6.63 into 10 to the power minus 34. And frequency we don't know, so we are finding, so 0.4 into 10 to the power minus 19 divided by 6.63 into 10 to the power minus 34. When we divide the two values, we'll get the frequency, which will come out about 6.03 into 10 to the power 13. 6.03 into 10 to the power 13 hertz. So this is a frequency of a photon, or frequency of a wave which is emitted out when electron transit from the smallest possible difference, from level 3 to level 2. If the same question was there, highest frequency, so highest frequency means greater jump. Shortest frequency or shorter frequency, or if they say, keep one thing in mind, energy and wavelength are inversely proportional. So if they ask longer wavelength, so we also need a shorter. So they can say which transition leads to a longer wavelength or which transition leads to a shorter frequency. That's having the same meaning, because frequency and wavelength are inversely proportional. Same thing, frequency and energy are inversely proportional. Then calculate how much energy in electron volt would be required to ionize. Ionize means, excuse me. The term ionize means removal of electron from an atom. We got, and from a ground state. So we want to ionize. We want to remove the electron from the ground state to outside. So how much energy we need? The difference in energy is 6.4. So energy needed is 6.4 into 10 to the power minus 19 joule. But in the question they're asking electron volt, like how many electron volt. So 1 electron volt is equals to 1.6 into 10 to the power minus 19 of the joule. So if we have 6.4 into 10 to the power minus 19 joule, how many electron volt will be there? X cross multiply. So this will come out around 4 electron volts. So we need 4 electron volts to transit this electron from the ground level till the point outside the atom. So we call that as ionization. Because the term ionization refers to energy needed to remove electron from neutral gaseous atom. The next question, question 3, which is about what is meant by a photon. The term photon means it's a packet of energy, or so you can say packet, you can say package, or a packet with a quantized energy, a fixed amount of energy is there. In short, you can say packet of energy or quantized energy. Even quantum of energy, quantum of light, electromagnetic radiation. If you just write packet of energy, you will not score full mark, because you have to mention packet of quantized energy, like fixed or discrete energy. So 1 mark is for mentioning packet, 1 mark is for mentioning discrete or quantized energy. You will get the 2 marks. only packet you will write, you will not score. You will lose both of the marks. The diagram shows some energy level of an atom, as you can see, and the energy sometimes they give in electron volt, sometimes they give in joules. Most of the question in electron volt, and whenever you are using a formula E is equals to HF, the energy should always be in joules because the Planck constant value is for SI units, so that's why it should be in joule. What is meant by the energy level? So how we define energy level, or allowed or possible or discrete levels or discrete region, or region where electrons have a discrete energy, we call that as energy level. Or you can also say allowed energy of electron in an atom, or discrete or specific amount of energy for electron in an atom, we also called as energy level. I already typed that definition, that's why I'm not typing it again. Now, in the question, the transition between the energy levels are associated with the emission or absorption. Describe the emission of the lowest possible frequency photon for excited atom with these energy level and calculate the frequency. So first, we want the lowest possible. Lowest possible means minimum transition. So which one? So while looking at this, using the gap, the distance between the level, you can identify which one will be the lowest. So when you check which gap is the lowest, so this is from 4 to 5 is the shortest gap. So it means that will be the lowest frequency or the highest wavelength. So first we'll take the difference in the energy, because we have to work out first the difference in the energy. And to calculate this, the formula is E2 minus E1. The formula to calculate the difference in energy is E2 minus E1. That shows how much energy difference occur. So E2, the above higher level is called E2 and the lower level is called E1. So higher level is minus 0.38 electron volt, minus, and upper level is minus 0.55 electron volt. When I take a difference of these two energy levels, I'll get a positive answer because it's energy. Negative sign only shows that energy is used to bind the electron within the atom. So 0.17 electron volt is there, but as I mentioned, whenever you are finding a frequency using E is equals to HF, the energy should be in joule. So we have to convert into joule by using a formal ratio. 1 electron volt is 1.6 into 10 to the power minus 19 joule. So if you have 0.17 electron volt, this will be x joules. When we cross multiply, this will come out as 0.17 into 1.6 into 10 to the power minus 19. So 0.17 into 1.6. This will give us 0.27. So 0.272 into 10 to the power minus 19 joules. But now in the question we need a frequency. So E is equals to HF. E is the energy, which is 0.27 into 10 to the power minus 19. The Planck's constant H is fixed, which is 6.63 into 10 to the power minus 34, and F is the frequency. When we simplify, we'll get the frequency of a photon which is emitted out. That will come out as 4.1 into 10 to the power 13. That's a frequency, hertz. And then so this is the energy of the photon which is emitted out, and the shortest frequency or least energy emission. So we have to describe the lowest frequency of a photon. So we will mention that will be from transition from fourth shell to fifth shell. Sorry, fifth shell to fourth shell, because it is emission. And reason is that because they have a shorter difference between, or smaller difference between the energy of the two levels, which leads to a energy emission of low frequency. If they ask highest, then there should be a greater gap. Lowest means the smaller gap should be there. and then most of the marks are for calculating that frequency. Photograph shows a flame test carried out on some of the chemical compound. The flame tests are used to identify the presence of element in some chemical so sodium compound produce a yellow flame because the spectrum of a sodium include a light of frequency 5.1. Before sodium compound is vaporized, the electron involved is producing the yellow light are in the energy minus 5.14 electron volt. So what is meant by the energy? So energy level, again the same definition for energy level. It's like discrete or allowed energy of electron, or discrete energy of electron, or specific energy of an electron is known as energy level. Why the light is emitted when sodium compound is vaporized? What is the reason why the light is emitted when these compounds are vaporized? So what happened? The electron gain energy, it will jump to higher level, and when this electron move or return back or fall back to a lower level, it will emit out a a photon which leads to certain color. The diagram represent the energy level 5.14 in sodium. Calculate the energy of calculate energy of another level involve, and add this level to a diagram and label the value correctly. So we have one of the level is there, and energy emitted out is also given. A frequency is given 5.15 into 10 to the power 14. So using this frequency, we will work out first how much energy is there, and using the energy we'll work out the difference, because that is equals to difference. So E is equals to HF. So energy is equals to Planck's constant, which is 6.63 into 10 to the power minus 34 times the frequency which is emitted out, 5.1 into 10 to the power 14. When we multiply, we'll get the energy in joules, but energy level diagram, energy is given in electron volt. So we have to convert this joules, which is 3.38 into 10 to the power minus 19 joules. We have to convert into electron volt. So we divide by 1.6 into 10 to the power minus 19, because 1 electron volt is 1.6 into 10 to the power minus 19 joule. So we'll get the answer in electron volt, which is 2.11. So means the energy difference is 2.11, and because it's an emission here, so 2.11 is the energy difference. So another level when we draw, so where we should draw 2.11 should be the difference. So if energy level 2.11 is a difference, so 5.14, because the formula is E2 minus E1 is equals to delta E. So we know the energy difference, which is 2.11. We don't know the final, and we know this is 5.14. So minus minus plus, it will move other side, so it will become as minus 3.03. So it means the energy of the second level is minus 3.03 electron volt. Is it clear how we work out the energy of the second level? Because first, using a frequency, we work out the difference in the energy, and using the difference in energy was 2.11 electron volt. The difference in energy 2.11 electron volt, so we work out the energy of the new level. And the last part, they ask why different elements produce a different spectra. So what is the reason? As I mentioned, every element is having a different gap between the shell, so different elements have difference in energy levels, and that's why they give out different photons. So different elements have difference in energy levels. Like the difference in the energy level is not same, and as a result they emit different photons. So this answer is having a lot of different and difference, because it's related to the different elements have difference in the energy level, and because of the difference in energy level, there are different energies or frequencies emitted out when the electrons are excited. So this was about the spectra. There are more questions, but I will share this with you and you will solve the remaining questions.